Okay, so the last way we can shift an equilibrium is through pressure, okay? So this only really works when you have an equation with gases in it. So again, I kind of cheated here a little bit and I've changed the states of matter on some of these to gases, right? That's cheating. These aren't really gases, but we're just trying to show you how the equilibrium will shift. So basically, when it comes to pressure, you need to remember gases take up a lot of space, right? Water in its gas form, like steam, takes up way more space than a liquid or a solid. And so when you add pressure to a system, it's going to try and shift to the side of the reaction that takes up the least amount of space, right? Right, if a lot of people are crowded into a room, they're going to want to like leak into the spots that, have more space or try to take up less space. They're not going to really spread out as much as they can. So reactions are the same way. If we increase pressure, we want to go to the side with the least amount of gases. So how do we keep track of that? Well, we need to count up our gases. So this number in front, this coefficient, tells us how many of the gas we have, right? So we're not going to count this one because it's not a gas. This is aqueous. So this would not count at all. This one, there's 4 chlorine gases, right? So we have 4 total gases on our reactant side. How many do we have on our product side? Well, this is a gas, and remember, if it doesn't have a number here, that just means we have 1 of them. And then we have, this is a gas, we have 6 of these. So total, on our product side, we have 7 gases. So if we were to increase the pressure of the system, it wants to go to the side that takes up less space. The side that takes up less space is the side with the least amount of gas, because gases take up a ton of space. So if we increase the pressure, right, we're going to be shifting our reaction this time into this direction, right? So what will end up happening is we'll have more of this and less of these, right? And then the exact opposite is also true, right? If we go in here real quick, get rid of this. What if we decrease the pressure? Well, if we decrease the pressure, those gases, they want to take up that space. When there's no pressure, that means there's lots and lots of space to move into. And so what happens is you want to favor the side that has more gases, right? So we're going to be favoring, in this case, our product side, which means that these guys are reacting and going away, and these guys are being produced and increasing, okay? Let's see if we can see this with this reaction here. So if we look at this reaction here, I'm going to press play so we can get it to equilibrium, right? So remember, we have to let these settle out. We have to let this graph kind of settle out. But at some point, we'll get to equilibrium. And then notice both of these are gases. NO2 is a gas and N2O4 is a gas. So once they get to equilibrium, we're going to try and shift that equilibrium away a little bit by adding some pressure. Okay, so while it's getting to equilibrium, let's go and make a prediction here. If we add some pressure, what are we going to want? What are we going to get more of, the NO2 or the N2O4? Well, they're both gases. So on our reactant side with the NO2, we have 2 gases, and with N2O4, we only have 1 gas. So if we add more pressure, we expect it to go to the side with the least amount of gases. That'd be our products, N2O4. So let's check if we have equilibrium yet. So I'm looking at these graphs, and notice that the lines have kind of flattened out. Our bar graph isn't really changing a whole lot. This is equilibrium, right? So it's at something. Do we have values here? We can't really see the NO2. Let's see, do we have values here? So our NO2 is what? Sitting around 14 maybe? Or yeah, sitting around 13, 14. And our N2O4 is sitting around 5. So let's add some pressure and see what happens after we add this pressure. So we just added a bunch of pressure. So we're predicting we get more N2O4. Look what's happening with that bar graph. Wow. Our N2O4 is definitely going up, and our NO2 is going down, right? And if we look at the graph here, let's see. Yeah, look at that. Changed it. So basically, our N2O4 is going up, our NO2 is going down. It's exactly what we predicted, right? And the reason is all that pressure is pushing these things into the smaller side of the reaction, so the side with less gas.